continuation of lesson 4. In our previous lesson, we did arithmetic calculation like addition, subtraction, multiplication, but we also added floats. we introduced floats into the whole system. That's assigning floats to a variable. Okay. There was something I left out, which I'll add to this. Something I should have added to lesson 3 when we're assigning string variables. So I'll add that, a simpler way to assign string variables, and then we do if and while statements while using comparisons. That's which is also more like falls under operations or arithmetic stuff. So let's quickly go on to it. Just know that though I'm doing it in the IDE, you can also do this directly in Tinkercad. Once you pull your Arduino board in, and then you change, make sure you change from blocks to text. That shouldn't be there. So whatever I'm going to do, you can do the same here. And your serial monitor is here as usual. So let's go here. Okay. So let me quickly do what I forgot. So string. So the other time we were using a variable called character. So kind of like char, right? And then let's say char a. Then we would have have this, and then we'll give it a string. Let us turn in the light on, right? Okay, so that's what we did. Where are my stuff? Okay, so that's what we did. But instead of doing that, a simpler way to do it is just string. String. So let's say string A. Then we will have turn the light on. Right. So let's do serial. Let's begin. Serial board rates 9600. Sometimes it's hard for me to find certain. My keyboard is a bit different, so it's hard for me to find certain things. So in case I take a little longer, just it's hard for me to find some symbols and characters on my keyboard. So serial dot begin, then we can say serial dot print line. Let me change this to off so that you can tell if there's any error. Serial dot print line. Let me change this to be serial dot print line A. Then serial dot print line B. Okay, so let's run that. And I see our monitor. What did I do? Sorry. Semicolons. Jeez. Okay, so we open. So we see turn light on, turn light off. So these two do the same thing. The thing with character is that this one behaves like an array, right? And when we do arrays, understand better. This one behaves like an array. This takes the T, takes the U, takes the R, takes them one by one, and then places them in an array. But this one just stores the entire string, like stores everything just like that. Okay, so instead of char a square brackets open close, you can just type string and then store your string variable. Okay, so let's go to officially today's the continuation of lesson 4. Let's quickly do that. If we do that, sorry. Well, I just want to make sure I'm following my own notes. Okay, so first, to understanding the comparison operations. Okay, so we're going to write a simple program. So int a, so just our normal variables. A is equal to, let's say, 5. B is equal to, so we are going to basically compare these numbers, and based on the comparison we print something. You get me? So in comparing things, you are usually using f. Is this greater than that? Is that greater than this? That kind of thing. So to do that, we write if. Okay. Please, sorry. We first have to activate our serial monitor. 9600 baud rate. Then we come here.
I've used the number, but I don't still not recognizing. I don't know.
Sorry for that. Then we come, where are we? What was that? So then we come here, we say if, right? If A is greater than B, right? And what should we do? We should, so I mean, at this point you are teaching the syntax, so the student needs to be able to do these things. So if A is greater than B, then serial dot print line saying what? A is greater than B. Boom. Then we'll have, so usually if you are based on one condition, you say if this, that, else, then do this. But we are writing multiple conditions, so else if. So anytime we are writing multiple conditions, then we are using else if A is less than what? B. We should one easy way you can do this is by like copying and pasting, and just changing the little things you have to change in it. But I'm writing everything because initially the student needs to write everything so that he or she will get used to it. A less than B. Okay, so we have that. Then another else if A is equal to else if A is equal to B, we serial dot print line saying what? A is equal to B. So right here we've used comparisons. Now just so that you know, The comparison we've used so far is greater than, less than, equal to. But we can also use greater than or equal to. So that's something like, or greater than or equal to. That's something like this. You see? But we're not doing that. But then you can use that. So those are other operations or comparisons. One of the things that I'm encouraged is that while you teach, also let the student go to. Let's say you are coming to do. Let's say you are doing if statements. So you can do Arduino.cc if statement. Basically, what's happening is that there are documentations for every code you want to write. There are documentations. So the student should get used to searching for documentations. So you open the documentation for if statements, you get it, and have him look at it. Okay, how is the structure? So this is how an if statement is structured. If with a bracket open, this is the condition, and this is the statement. You get me? What should happen in that case? So at least this allow the student to know how to look for documentations, so that if he or she is writing a new program he or she has not worked with before, then you know what to do. Okay, so over here you can see the bracket may be omitted after an if statement. If this is done, the next line becomes the only condition. So if you are writing just one condition, if this that, then get me? Yeah, that's only if you're writing just one condition. You can omit the word, the bracket. So documentations help, because then what happens is that code changes as the version of the program changes. The code sometimes changes, so you don't want to teach a student in a way that he or she thinks this is the only way, or is just do or die, but allow him to find the actual source of what he or she is doing. So I encourage that you always kind of help the child see, okay, where is this coming from? Is there a documentation for this? How did you yourself even know this in the first place? You get what I'm saying? Yeah. So let's come back here. So now we've written all this. Are we done? Yeah. Else if this, else if this, else if that. Okay. So we're done with this. Let's upload it. There's some blah 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 happening here. Okay, as usual. Semicolon is the enemy. Okay, not really. It's not really the enemy. Okay, so done uploading. So we open, and A is less than B, A is less than B, because we said A is 5, so A is less than B. One thing we can do just to make our program is to always, before you even write a code, put a delay command in there. You get me? Put a delay command in just a few microseconds. Wow. Yeah, just to it will make so that things are not running. Your text is not running all over your serial monitor, but it just okay. This is still running. Let's make it 100. Let's make it 100, so that it kind of looks. It's easier to read and it's easier to tell what is happening. At least this is better. It's still fast, but it's better. So we say A is less than B, A is less than B, A is less than B. So let's just play around with the figures. Let's change A to, you can change A to anything, but let's change it to 10. So I mean, we just want to see if all our if statements are working. All our if statements are working or is working. Whatever. So here you see A is greater than B. So the first one was A is less than B when A was 5. Now A is 10, so A is greater than B. Now let's make B also 10. And let's see if our code is really, really, really working. Really working. So here you have A is equal to B. Voila. Okay, so I think that brings us to the end. Let me check documentation. So yeah, understand comparison. Oh, while statements. Okay, so let's do while statements. So I like a while statement. So now we've done this, blah blah blah. Okay, so let's remove this. Now we're going to, so while statements are usually used to write a program which you want that program to only run when a certain condition exists, right? So we're going to write a statement and say, while, let me see, while, let's say while A is less than or equal, okay, so let's use the another comparison. So while A is less than or equal to while A is less than or equal to 20, right? Because here A is less than 20. So while A is less than or equal to 20, what should happen? Well, a serial dot print line A is less than 20. Let me add less than or equal to. It's less than, sorry. It's less than or equal to 20. Okay. So A is less than or equal to 20. But then we want to say wow. So we want the code to stop at a point. So what we're going to do is that we are going to be increasing A, right? So what we'll do is that we'll say A is equal to, sorry, A plus 1. Now, what this is going to do is that the code is going to repeat A is less than 20. So it will print A is less than 20, then it will increase A by 1. I think when we did operations, we did something like this. A is equal to A plus 1. If we didn't, I'm sorry. But then take note, you can change the value of a variable, right? So if let's say here you wrote A is equal to 10, and here you come and write, remember this is a global variable, this is a local variable. So if you say A is equal to 10, okay, and then later you write A is equal to 20, know that A will now be equal to 20 and no longer 10, because it will read, it will act based on the last assignment that you did. So when you write while this A is equal to A plus 1, this A is recognized as what? As 10. And now this will now be 20. So it will run, because while is a loop, so it will run. Now when it comes back to run, it will recognize this as, so 10 plus 1 will give you 11. The next time it comes, they recognize this A as 11, and hence so it will keep increasing 11 up to the point where it gets to 20. Once it gets to 21, now A is no longer less or equal to 20. It's now greater than, and the code will stop running. So let's test that and see. We're uploading onto. So we expect this to kind of print like 10 times. You see? So A is less than 20. At that point, A was 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Once A went to 21, the code stopped, right? So you use while to repeat a process until that condition does not exist. So let's say you want to say, let's say while it's evening, the light should be on. Begin. That means that once the light in the atmosphere goes to something, that while code will no longer run. Do you get it? Okay. So that's it. We've used if, we've used while, and that brings us to the end of lesson 4. I'll upload lesson 5 shortly. Thank you for staying.